Hey y'all, this video is on intercepts and it's also on a form of the equation of a line called standard form. The x and y intercepts of a graph are the points at which the graph crosses the x and the y axis. Crosses or, touches, just has to touch it. Now notice in this case I have an x-intercept at -4 and a y-intercept at 6. Let's practice finding intercepts from a graph. The blue line is the graph. It crosses the y-axis at 0, 3, that's the y-intercept, and it crosses the x-axis at 15, 0, that's the x-intercept. The standard form of the equation of a line is a form of the equation where the x term and the y term are on the same side of the equation, and the constant term, or the number, is on the other side. For example, 3x minus 2y equals 6. Let's practice finding intercepts from an equation. Find the x and y intercepts of the function 3x minus 2y equals 6 and draw the graph. The y-intercept occurs when x is 0. So what I'm going to do is plug 0 in for x. So 3 times 0 minus 2y equals 6. Now when you multiply 3 by 0, you get 0. So that term completely drops out of the equation. Negative 2y equals 6. If we want to isolate y, we need to divide by negative 2 to make a 1. Now if I divide on the left by negative 2, I also have to divide on the right by negative 2, and you can see that y is equal to negative 3. That's my y-intercept. To find the x-intercept, you want to do the same process, but this time we're going to plug in, let's use green, we're going to plug in 0 in place of the y in the equation. Now when you multiply 2 by 0, you get 0. So that's gone, leaving 3x equals 6. I want to isolate x, so I need to make a 1. And if I do it to the left side, I have to do it to the right side. 6 divided by 3 is 2. So my x-intercept is 2. Now I'm going to plot negative 3 on the y-axis. I'm going to plot positive 2 on the x-axis. And then I connect them with a straight line. And there's my graph. We're going to practice this again, but I want you to notice that my equation is not in standard form. To put it in standard form, I have to move this negative y to the other side of the equation. So I have x equals negative y plus 6. I'm going to add y to both sides because negative y plus y makes a 0. And now I have x plus y on the left equals 6 on the right. When I plug in 0 for x, I see that I'm left with y equals 6. So that's the y-intercept. When I plug in 0 for y, I get x plus 0 equals 6. And adding 0 changes nothing. So that's just x equals 6. Now, my graph paper is a little too small to plot 6's, but it's no big deal. I'm just going to figure out where 6 would be. So x equals 6 is right over here, and y equals 6 is right up here. I'm going to connect those two dots with a straight line, and there's my graph. One more example. 4x plus 3y plus 12 equals 0 is not in standard form. We need to move the 12, the constant, to the other side, and I do that using subtraction. So I subtract 12 from both sides, And now I have standard form. When I plug in 0 for x, 4 times 0 is 0, so that drops completely out. To isolate y, I divide both sides by 3, and I have y equals negative 12 divided by 3 is negative 4, and that's my y-intercept. Now I'm going to plug in 0 for y. I think I lost something there, 3y. All right, so I'm going to plug 0 in for y. I get 4x plus 3 times 0 equals negative 12. 3 times 0 is 0. I have 4x equals negative 12. So I divide both sides by 4 to make a 1. And I have x on the left equals negative 3 on the right. And that's my x-intercept. So when I plot the y-intercept of negative 4 and the x-intercept of negative 3, I can then connect my dots and extend to draw the graph of that particular equation. All right, now we're going to find x and y-intercepts by examining a table. Sometimes this is a little bit like a puzzle, but it's not hard to figure out. Now, in the first table, this 12, 0 is the x-intercept. So that was just straight up given to me. So remember, when y is 0, that's the x-intercept. But notice we don't see x equals 0. Now here's where a little bit of logic comes in. And if you play video games, you do stuff like this all the time. It's just logical. Just don't let it scare you. So starting at the bottom of the table, x goes from 12 to 9 to 6 to 3. We're losing 3 each time. If I lose 3 one more time, I'm going to be at 0. So what I need to do is continue the pattern in the y column. 0, negative 2, negative 4, negative 6. The next number would be negative 8. So 0, negative 8 is the y-intercept. It's just a little bit of logic there. Now the middle table, well, this is a gift because you see 0 in the x column. You also see 0 in the y column. So 0, 7 is your y-intercept, and negative 7, 0 is your x-intercept. So those are straight up given. In the last table, I do see a 0 in the y column. So 3 is my x-intercept. But I don't see a 0 in the x column. But if you follow the pattern backwards, 4, 3, 2, 1, 0's next. And then so I just follow the same pattern in the y column. 5, 0, negative 5, negative 10. We're dropping backwards by 5, so that's negative 15. And this is your y-intercept. Okay? Now, using standard form to find intercepts is often called the intercept method of graphing a line. So I actually call this method cover-up. So this is my little summary. The y-intercept occurs when x is 0. When you plug in 0 for x, the x term disappears. And what are you left with? You're left with y equals 6. So that's your y-intercept. Now we can do the same thing when y is equal to 0. When y is equal to 0, this y drops out and you're left with 3x equals 6. Well, 3x equals 6. Isolate x by making a 1 using division, and you get x equals 2, and that's your x-intercept. So if I were doing this on paper, I would just take my finger and I would cover up the x and find y, and then I would cover up the y and find x. The intercept method, I call it cover up. That's it. Thank you for watching.